Alright guys, welcome back. Hopefully this week is a little bit nicer than last week. I don't actually know what the weather looks like, but I'm making this on Friday. So if you have any questions on the first part, let me know. But this second part, not super complicated, just different. So like when you multiply matrices together, besides scalar multiplication, you have to just be careful, okay? This first question is scalar matrix multiplication, so it's actually very similar to what we did last class. You're doing 3a minus b. I want you to just see if you can try it, and then I'll show the work in a little bit. So just pause it. All right, hopefully everyone got the final, which was 4, 6, 12, negative 10, negative 1, negative 6, 7, 0, 4. So you have to multiply your first equation, your first matrix by 3. So that's what I did here. The thing you have to be careful of it with subtraction is if it has a negative, just make sure to distribute that negative. So, like I just noticed I did one of them wrong. So like 0 minus negative 4 is actually 4, not negative 1. I don't know where that came from. Sorry. And then like negative 3 minus 3 is negative 6, and 6 minus negative 1 is 7. So just be careful on some of those. So moving on to our matrix multiplication, I want you to think about when we did the augmented matrix. It's very similar to this example. So I want you to just take a second and think about back to what we did with that. When we go through the matrix multiplication, you have to think that your first row is all different variables. If you multiplied it by another matrix, it'd be like multiplying by constants, so you'd have to multiply vertically. Okay, so what that will look like is what we're going to do for the next part. So just a heads up about some of these rules. Addition is commutative, which means that if I do two matrices added together, if you flip-flop them and add them, it's the same thing. Same thing with if you multiply by an identity. Identities are like multiplying by 1. So if you multiply by 1, it gives you the same answer. I'll show you more about what identities are later. If you add 0, like if you add a 0 matrix, you end up with the same matrix back. That hopefully makes sense. So we're going to start small and go through matrix multiplication again. It says you could either use the distributive property on something like this question. Personally, I would not. It says you can distribute the 3. I actually would find it easier to add these two matrices first, then distribute the 3. I don't know how you guys feel, but to me, multiplying by 3 twice, then adding together is more annoying. So I would combine like terms for the two matrices given. So I'd get 2, negative 2, 7, and 8, and then multiply by 3, and you get the same answer. So why do more work? That's not 8. Sorry. It's 24. Okay. Anyway, basic. Okay, matrix multiplication. Give yourself a lot of room. So for this first question, if you can do it on separate paper, if you're doing this through rewrite, just try to zoom in a little bit so you can give yourself lots of room here. What I'm going to do first is just show you how these work. So with matrix multiplication, the first thing you need to make sure that you have are the same inner dimensions. Okay, you have to have the same inner dimensions to multiply matrices. Your result is going to be the outer dimensions. So I always label what my dimensions are first. So this is a 3 by 2, and then this is a 2 by 2. So we're good to multiply them because the inside dimensions match, and your final answer is going to be a 3 by 2 matrix, okay, because the outer dimensions are 3 by 2. Now, to multiply matrices, I'm actually going to erase this so you can see it a little better. You always want to multiply row by column. So I'm going to just circle the first row and the second matrices column, okay? That'll give me my first row, first column answers. Okay, so I'm going to do all the math out over here, and then our final step will just be to combine like terms. Okay, so I'm going to do the first one in black because they're both circled in black. What you want to do is always go for each term by the row, by each term by the column. So what that looks like is you take -1 and multiply it by -3. Then you add the next term in your row by the next term in the column. So 3 times -4. Okay, and that gives you your first row, first column answer, because you're going to get one number back. So I'm just going to simplify that so you can see how this looks. Again, you're going to end up with a 3 by 2. So you end up with 3 minus 12, which is -9. So that's your first number answer, okay? Now let's do the first row, second column. So I'm going to do this in red, okay? That is going to give us this number. Again, first row, second column. So again, I'm going to look at my first row for my first matrix, second column for my second matrix. Again, it's always row by column. So this is going to be -1 times 2 plus, then again you go to the second term in each of them, 3 times 1. And if you simplify that, you get 1 back. Okay, it's a 3 by 2, which means I only have 2 columns, which means I'm done with that first row. So check, I'm good. Okay, but I need 3 rows, 2 columns, okay? So to get my next one, I'm going to again circle in a different color. Actually, in fact, I'm going to erase what I had already circled just so you guys can see it in a different color. If you can do it in different colors too, that would be lovely because it helps. Okay, so now we're looking at the second row, first column, right? We're looking for this number right here. So second row, second row, first column. So we're going to circle second row and the first column of each of our matrices. Okay, so what's going to go here is 4 times -3. And those of us who are getting the hang of this hopefully recognize the second thing you're going to do is multiply -2 by -4. So the nice thing is you don't have to multiply each number by each number. You're kind of sliding horizontally and vertically at the same time, which hopefully you can see also that this gets a little complicated. We're going to do lots of practice on this, so don't panic yet. So -12, and then we're going to add -8 to that, it looks like, or +8, sorry. So -12 plus 8 is going to be -4. All right, next one, we're going to do this whole question together just so you can see how it works. Let's highlight. Again, we're still on the second row, but now we need the second column, and that goes here. So we have to do 4 times 2 plus -2 times 1. So you get 8 minus 2 is 6. Second row done. Okay. Now we need our last row, last columns. Okay, so I'm going to again erase that. So if we're looking for our last row's answers, we need to circle the last row. Okay. Then we have to look at our first column for our first answer again. So let's do 5 times -3 plus, that's right, 0 times -4. Hopefully we're getting the hang of this. Okay, so you get -15 plus 0, -15. I want you to try to do the last number on your own if you can. If you cannot, if you don't feel confident yet, don't worry about it, and I'm just going to keep going. But if you're feeling good, pause it, try it, and then you should get the same answer. All right, so I'm going to do this in black again because we're doing our last column. So 5 times 2 plus 0 times 1, so you get 10. And your final matrix is what you see in front of you. So hopefully you're good. So it's 9, or -9, 1, -4, 6, -15, 10. So it's a little tedious at first, but once you get the hang of it, you're just going to fly through these. So don't worry yet if you're like not sure where it's going. The next question they actually did for you I'm going to have you try a few more on your own in a little bit, but if you want to just do the workout for any of 3 of these just to make sure you're good, please feel free. Just a reminder that you are allowed to multiply these 2 because the inner dimensions match, and you're going to get a 2 by 3 as an answer. So you should always check your answer and make sure it makes sense, because again, the outer are what your final answer is going to be for dimensions. Your inner for the first here are 2, and you end up with a 2 by 2. Okay, if you ever need to check this, again, that's how it works. The other thing I want to point out on this question is that 1001 is actually the identity matrix for a 2 by 2. What that means is you have 1x, 0y, 0x, 1y. So it's literally like you're just multiplying by 1, because notice you get the same matrix back. This is called an inverse matrix if you get the identity back, okay? Again, you end up canceling a lot of these numbers out, which is why you get zeros across the diagonal, okay? So in identity, you end up with 1s along the right-hand diagonal and then 0s along the other. Okay, we're going to do this next one again together because I think it'll help to do one more practice together, and then we'll just do a few more problems on our own. These are a little bit harder when they have singular dimensions, meaning this is a 1 by 3, this is a 3 by 1. So what's weird about this is, yes, you can multiply them. Your answer is going to be a 1 by 1 matrix, which literally means it's one number. Okay, so I'm going to do the math out with you, and then your answer is literally just going to be one number. So row by column, right? So we're going to do 1 times 2, because there's only one row and one column. So you're going to do 1 times 2 plus -2 times -1. Again, we're going horizontally and down at the same time. Plus -3 times 1. Okay, so that gives you one number. It helps to think about what the final dimensions are going to be. Okay, so that's how I knew I just had to add up all the numbers. So 2 plus 2 is 4, minus 3 is 1. Weirdly enough, you get 1 as your answer. Okay, try the letter E for me, and then check out why F you cannot multiply. All right, check your answers for me. It should be this matrix that you got. So just a reminder that it's a 3 by 1 and a 1 by 3. The insides match, so we're good. But you're going to end up with a 3 by 3, which is kind of weird because it doesn't look like a lot of numbers. So what's weird is if you want the first row, first column, you don't have to add it to anything because there's no other numbers in your first row and first column. So you're literally just multiplying your first few values by 2, right? Because it's that first row is literally just 2 times all those numbers. Your second row is -1 times all of those numbers. And then your third row is 1 times all those numbers. So it actually is a little bit less work, but it looks strange. So that's why I wanted to go through it. The second one, hopefully you're recognizing that you can't multiply them because this is a 3 by 2. This is a 3 by 4. The insides don't match, so you can't multiply. Okay, the insides have to match. The next one says to use a graphing calculator to multiply, but we're not doing that yet. We're going to do it all in 1 week after next week. So we're going to do this by hand. So this is a 2 by 3. This is a 3 by 3. So your final answer should end up being a 2 by 3. Okay, so check that when you're all done, but pause it. I want you to try this one on your own and see what you get. All right, guys, check the work and your solution. You should have had 8, 4, 10, -25, 16, 5. So if you need to see the work done out, just a reminder, it's row by column always. So first row, first column gives you the 8. First row, second column gives you the 4. First row, third column gives you the 10. So the math that you do is always 1 times whatever's first, 2 times whatever's in the second row, and then 3 times whatever's in the third, and so on. Okay, if you need me to go through this with you a little slower, feel free to join my office hours. We're just going to look at one more thing before we're which is not a lot of work for you, which is nice. But the only bad thing is when you multiply matrices, you have to be careful because A times B is not necessarily the same thing as B times A, okay? But I also want to remind you of what the identities are. So an identity is like multiplying a matrix by 1. Because of the way matrix multiplication works, for a 2 by 2 matrix, your identity, and this is only for square matrices, is always 1, 0, 0, 1. And we denote that with an I for the identity. A 3 by 3 is the only other identity you're going to have to know, and it's 1, 0, 0, 0, 1, 0, 0, 0, 1. The easiest way to remember is the ones are along the diagonal, and then everything else is zeros. So if you were to do a 4 by 4, it would look like 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and finally 0, 0, 0, 1. Okay, but you again won't have to know that. It's like multiplying by 1 because of the way that matrix multiplication works. That is all that we are going to do from this chapter right now. Eventually we're going to get through solving systems using matrices, so hold off on doing those yet. We're going to do a little bit in the next week, but then a lot more in the graphing calculator the following. All right, enjoy your day, guys.